Okay, so here we're talking about those things: LCD, LCM. So what are those things? So let's check it. Suppose we have those numbers like 12, 18, 24. For those three numbers, we know 2 is a fact for each of them, right? And 3 is also a fact of them. And 6, all those, each one is a factor or divide of them. So so we can say like those 2 is a common divider. So among this common divider, 6 is the largest one, right? So we call this 6 is largest common divider. So this is the LCD. Okay. So this LCD, this number has different names. Some people say largest common factor, right? Largest common factor or largest common divider, or greatest common divider. Like we can say like there's 2, 3, 6. Each one is a divider. So we just pick a largest one or greatest one. So sometimes we denote it GCD. So all those 3 things are same. Okay. So we find here the 6 is the largest common divider. So do we have smallest common divider? Do we have smallest common divider? Answer is yes. There is smallest just 1. 1 is always a fact for any other number, right? But this such a conclusion useless, because 1 always is 1, always is 1, right? The smallest common divider always is 1. So here we have no much interest for that. So we just focus on largest common divider, right? Okay, so how can we find those LCD? So we have a simple way. We just for this number, we just factor this number as this. For B, this number. Or if we have many numbers, we just factor them as a product of prime numbers. So the LCD, we just pick for each exponent. For P1's exponent, we just pick a smaller one. For P2's exponent, we just pick a smaller one, like that. Okay, so now suppose like we want to find LCF, or largest common factor with us. There's 3 numbers. So we just use fact, right? 12 equal to 2 times 3, and 18 equal 2 times 3, 2, right? And 24 equal 2, 3 times 3, 1, right? Okay, so then this LCA for this 3 number equals, so we just check 2, so 2, so we just pick, here's 2, 1, 2, 2, 2, 2, 1, 2, 3, so that's 2, 1. And 3, so here's 1, 2, 1, so smaller is the 1. So this equals 6. Okay. Okay, let's check the same problem. So 40A, so here we just need to check 40A. 40A equal 2, yeah, 40 just equal 2 times 24, yeah, so we can say 2, 4 times 3, 1. So 72. Let's say I know 72 is 2 times 36, 6 square, right? Okay, so 2 times 2 square, 3 square, so that's equal 2, 2, 3, 3, 2. Okay, so let me put it together like we say 48 equal 2, 4, 3, 1. And 72 equal 2, 3, 3, 2. Okay, so we can easily find this LCF equal, so we just pick a smaller one, so 2, 3, and 3, 1, 2, 3, 1, right? So we say, so this equal 24. Okay, so for those numbers like 3, 9, 12, 15, 8, so those just we call those as multiple of 3. Just 3 multiply 1. Oh, I'm sorry, I missed the 1. 3 multiply 1, 3 multiply 2, should have 6, right? 3 multiply 3, multiply 4, multiply 5, like that. And so multiply by 4, so 4, then multiply 2, so multiply 3, so we have those. So we call those number multiple of 4. So we find since 12 is a common multiple. 12 is multiple of 3 and also multiple of 4. So we call it a common multiple. Okay, so we have many, so the common multiple of 3 or 4. Now 12 is a common multiple, and 24 is also a common multiple, right? 24 is a multiple of 3, also multiple of 4, and we have many, right? Okay, so among those, we say this 12 is smallest. So we call this least common multiple, LCM, least common multiple. So least common multiple is actually nothing new. We already know this. Like when we're talking about addition for fraction, we use common denominator. So those common denominator is just the least common multiple. Like 3, 4, so we use common denominator 12, right? And 12, 18, we use 36, right? So those 36, we can say the common denominator. Also, this 36 is the LCM, least common multiple of 12 and 18, okay? Okay, so here we have a question. If we are given some numbers, how can we find their LCM? So the key point is we just factor this number A, factor this number B, then LCM, we just pick the maximum exponent. So here, let's say greatest common divisor or largest common factor. We just pick a smaller one. Here we just pick a maximum largest one. So let's check this problem. If we have 24, 36, we want to find the least common multiple. So let's say, so we just check 24. So we just figure 24 is 2, 3 times 3, 1, and 36 6, just 6 square, right? So 6 square just 2 to 2, 3, 2. Okay, so the least common multiple for them is just we just pick largest one. So 2, 3, 2, 2. So we just pick 2, 3, and 3, 1, 2. We just pick 2. Okay, so that's equal. So we just say 72 is least common multiple of 24 and 36. So actually we know that 72 equal 24 multiply 3, right? And also 72 equal 36 multiply 2. So these are the smallest. We just become, we also can say that multiply the smallest number. Okay, 24 multiplies 3 will be enough. 36 multiply 2. Okay. So use this way, we can easily find the least common multiple. So let's say, so there's a problem is just the okay, just the fact is 122 and 312. Yeah. Okay. So here we just take some time. Just only things that take some time. Fact is 122. And I think 12 multiplied 10, so 12 is 2 times 3, 1, then 10 is 2, 5. Okay, equal to 2, 3, 3, 1, 5, 1. And do the same thing, right? Okay, so once we can factor those two numbers, so we can easily find LCM. We just pick a maximum or largest. We just pick a large those exponent. Okay. Okay, so here we introduce a new notation. We say like for those 12, 18, we find there's 6 is the largest common divide. So for 7, the largest common multiple, only one common factor. So we also can say this largest common factor is 1. Okay, so if largest common divisor is 1, we just call those things mutually prime numbers. Like 4, 7, we do not have common. We can say we do not. How can I say that? We mutually those two numbers prime. Okay. So here this is new notation. Prime, so okay, mutual prime. Okay. Okay. So what is some application for LCD, LCM, or those mutual prime? So typical example is, can I pay off my debit? Suppose like I owe your daddy $3, but I do not have $3. If I have $1 bills, I just give $3, right? But the question, I do not have $3. I have some $5. I have five. I have just only 5 bills, and you did only $10. 10. So in this case, I cannot pay off. I cannot, like basically just from 5 and from 10, I cannot make a 3, right? I can make it 5, make it 10, make it 15, but I cannot make it 3. Okay, so now if like I have those 5, 5, 5, I have those numbers, and your daddy has 2, 2, 2, 2, then I can easily make 3, right? So I just give your daddy $5, then your daddy give me back $2. Then I pay your daddy $3, right? Okay. So now let's consider the problem. Like I have 5, 5, 5. I have only some $5 bills, and your daddy has only some $10 bills. Then we just check which payment can be made. So we can say 5 is okay, 10 is okay, but all other not okay. Like 20, 22, I can make 20. 20 is okay, but there's 2 not okay, right? Okay. So why there's 2 not okay? Because we say those 5 and 10, from 5 to 10, we cannot make it 2. Okay, so here we have another question. Which, like from the 5, 5, from 5, those 5 and 10, which number, which can be made? Can be made. Okay, which one can be made? Not made. Okay, so we say, oh, this is such a problem, really easy. Can be 5. Okay, 10 is okay, right? 15, 20, all those are okay. So this is smallest number. So we focus on smallest. If we can make 5, then we can make 10, right? Just double, or 13, right? Okay, so this number is just LCD. Okay, so LCD for 5, 10 equal 5, right? Okay, so here we have this result. If D is LCD for AB, then this D can be made by those from A and B. So just K1 times A plus K2 times B. Okay, so let's say, okay, so let's consider the problem. So we say like this D we can make from AB. Okay, then double D, like 2D, 3D, or those things we can make. Okay, so now let's consider the problem. Like, okay, so from 12 and 21, let's suppose we have 12, we have many 12s, we have many 21. So from them, which kind of number we can make? We say we can make 3, then 6, or those things. The smallest number is 3. Okay, so we say LCD of 12 and 21 is 3. So where does 3 come from? Also, this is easy, right? We just check 12. 12 is 2 times 3. And 21 is 3 times 7, right? Okay, so here for 2, so here we have 2, 2, here we have 2, 0. So we have to say it's 2, 0. or we forget this. 2 0 is 1. For 3, so smallest 3 1. So 7 0, right? So we say this is 3. So we call this 3 is least common divisor. And we can also understand that 3 can be made from 12, some 12 and some 21. So let's try find this K1, K2 such that we can make a 3 from them. Oh, this actually easy, right? We say 3 just equal 2 times 12. 2 times 12, 24. So minus 21, right? So this is 3. So we can say there's a K1 that's 2 times 12 plus negative 1 times 21. Okay, so here K1, K2 just an integer, just can be positive, can be negative. Okay. So if we're talking about pay money, so suppose I have a 12 bill, you have 21 bill, so I can make $3. I just give you 2 of $12. Then you give me back $121, right? Okay. So for such a problem, this is easy. The least common denominator, common multiple. So we just say this equal just the common least LCD for those numbers. LCD. No. Here the common least common denominator LCM. So this is just a notation. 2, 3, 4, 5, 6, 7. So we can say like we just change this like 4 is 2 square, and 6 so 2 times 3. So we just check. So this equal just check 2. So we say highest 2 exponent is 2. Then we have 3. Most largest exponent is 1. Then 5. 1. Then 7. Right. So this is a common denominator. Okay. So there's a problem. What is the ratio of the least common multiple to greatest common factor? Okay, so we want to find least common multiple. So at the first we just factor this, like 180. 180 equal 18 multiplied 10. So 18 is equal 2 times 9. So 9 is 3 square. 10 is 2 times 5. So that's equal 2, 2, 3, 2, 5. Oh, this number is a little bit tough. So for this one, so at the first we say this one, so we need to factor this. So at the first this is even number, so we can this one have this factor as 2, right? So 2, let's say 19, 18, 9, 7, right? Okay. So this one is odd number, so we do not have 2. Then we say this one can divide by 3. So how can I know this one can be divided by 3, or 3 is a factor of this number? So we say, because 2 plus 9 plus 7 can be divided by 3. Okay, so divided by 3, 27. Okay, saying this can be divided by 3 or divided by 9, like 11. Okay, so this number can be written as 2 times 3, 9, so this is 3, 3, 11. Okay, so this leads you least common multiple. Least common multiple, we just pick this ratio, so we just pick a largest one. So 2, we just pick 2. 3, pick 3, and 5, 1, and 11. Right? We just pick largest one. Then greatest common factor, we just pick a smaller one. So here it becomes 2, 3, 2. So 5, or no 5, so smaller one is that. Okay, so this is the ratio. Okay, so we can do a little bit of calculation. So this becomes 2 times 3 times 5 times 11, right? So 2, 5 is 10, 6 times 32, so this equal 330. Okay, so we have the 2 numbers. Okay, we say we know least common multiple for AB is 12, and least common multiple for BC is 15. Then what is least common multiple of A and B? So we have many numbers, many A and B, such that their LCM is 12. So here we just pick, so because we have many, so we just pick smallest. So here we want to find the smallest. So let's check like, so we just let like A, B, we want to guarantee their common least common multiple is 12. So maybe we can put the A equals 3 and B equals 4. Or we want to we also can, let's say, put A equal 4, B equals 3, right? Okay, so because B and C, their multiple is 15, so we put C equal 5. So we just use this way. So if there's 3 numbers like this, so I think those numbers are smallest. A equals 4, B equals 3, C equals 5. Then those numbers satisfy the condition, right? This is the common multiple of AB is 12. This is the common multiple of BC is 15. Then what is AC? What is least common multiple of AC? So equal just the equal 4, 4, 5. So 4, 5 is 20. Least the common multiple is 20. Okay, so for this problem, Mr. Sanders, she has 3 grandchildren who call her regularly. So one, so we just suppose we have three grandchildren, ABC. So A call her every 3 days. B call her every 4 days, and C call her every 5 days. So all these three call her on that day. Okay, so last day of the year. So A, B, okay, C. So at that day, all these three call her, and A call her this way every 3 days. The B call every 4 days, and C call every 5 days, like that. So the question is, how many days during the next year? So next year we have 365 days. Like so among these 365 days, someday she receive a phone call from A or B or C, or from both of them, or from three of them. Someday she did not receive any call, right? So here we want to find this one, not how many not. So we just this how many not is equals 365 minus the number of call, having call. So this problem, so having call, we should put it together like just like that. Here call, then here one people call, here sometimes two people call, sometimes three call them. Okay, so for such a problem, we let's say number of calls, we say, so here we use this notation, like so here have some overlap, so we did not like A means A call, or we union A call or B call or C call, or so A or B or C. So here we use the Venn diagram. Let's say that this also like here A, suppose this is A, this is B, this is C. So here I have many overlaps. So we use this formula. So equal like A call, just like only we just check A call plus B call, that plus C call. Then we need a minus both of them call, like here A call, B call. We count that day twice, right? So we did a minus. Okay. So A and C, and minus A, B and C. Then we need a plus, say this three call, like okay. So here minus, we minus too many, so we just need plus. Okay. Okay. So like here, let's say A, suppose this is A, this is B. So we count for this part twice, so we need a minus. And C, so okay. So this part, A, B, C. We minus too many times, so we need a plus. Okay, so once we know the thing, so the problem becomes easy. So what is the NA? NA is just the 365 divided by 3. So 1 year costs so many times, right? And B, so 365 divided by 4. This is the quotient part. Okay. Okay. okay, so 365 divided by 5. Right? So minus, so what is A and B? So A and B is, how many A and B? Both of them call her. This is just the, so common denominator 12, like 3, 4, 12. So divided by 12. So 365 divided by 12. 330, right? So 30 day, both of them call her. And A and C is 4, 5, right? So common denominator 20. So 365 divided by 20. 28, right? So 18 days. Both of A and C call. So how about B and C? 3, 4, 5. Oh, I'm sorry. This is 3, 4, 5. 18 is maybe the A and C. Yeah. So B and C is 4, 5. So A and C is 3, 5, 15. So 365 divided by 15. So this is 2. So 64, 24. Yeah. Then plus the days that 3 of them call her. So 3, 4, 5. This equal 60, right? So divided by 60. So 3 divided by 60 is 6, right? So 6 days. They all of them, 3 of them just call her. Okay. Okay. So we need to find this number. So those numbers, this number is just the she received a call or receive calls. Maybe 1 call, maybe 2 call, maybe 3 call. Right? Okay, then another call just the 355 minus this number. Okay. Okay. So we just stop here.